Okay, guys, let's go over homework number 2. It says use inductive reasoning to predict the next number and the nth number in the sequence. Please show your work. Okay, so in order to do this, we need to know what inductive reasoning is. Inductive reasoning is assuming an answer will be what it is because it has always been that answer. Oops, let's see. So if we look at number 1, we'll use that reasoning and say, okay, between 7 and 13, we get 6. And from 13 to 19, we have 6. 19 to 25, we have 6. And 25 to 31, we have 6. Now, inductive reasoning lets us know what that next number would be. That next number would be 37 because we just assume with the inductive reasoning that it will continue to stay 6. So that next term would be 37. But in order to find the nth term in the sequence, we do n is equal to 1. The first term is 7. So 7, and this is an additive, so it would be 7 equals 7 plus 0. So n to the second position, so the second term, we have 13. So 13 is equal to 7 plus the 6. And then in the third space, so third term, we have 19. 19 is equal to 7 plus 6 plus 6. And we have in the fourth is 25. So 25 is equal to 7 plus 6 plus 6 plus 6. So we do have our pattern started, so we don't have to keep going. So to find the nth term, we take our starting number, which is the 7. So it's going to be 7. And it's adding, so we do 7 plus, and then we use our common difference, the 6. And it's going to be n, which is the term, minus 1. All right. So number 2, we have 2 to 4, we're multiplying by 2. 4 to the 8, we're multiplying by 2. 8 to 16, we're multiplying by 2. And 16 to 32, we're multiplying by 2. So using the inductive reasoning, we would see that we're assuming that the next term would be also multiplied by 2. So that would be 32 times 2, which would give us 64. So to find the nth term, we go n equals 1. First term is 2. 2 is going to be equal to, since we're multiplying, be 2 times 1. So our second term is 4, and that would be 4 is going to be equal to 2, our starting number, times the 2. And third, so our third term give us 8. 8 is going to be equal to our starting term times 2 times 2. And then our fourth term is going to be equal to 16. So 16 is equal to 2, our starting term, times 2 times 2 times 2. So to find the nth term, we use our starting term, which would be 2, times, since we're multiplying the difference, times 2, which is our difference. It's going to be n minus 1. Okay, so number 3, it says indicate whether the sequence is arithmetic, geometric, or neither. So arithmetic would be as if we're adding the next terms in the sequence, and geometric is if we're multiplying. So on this one, the difference, we have 5 to 9 is 4, 9 to 13 is 4, adding 4, 13 to 17, we're adding 4, 17 to 21, we're adding 4. Sorry. Then, so because we're adding, it's an arithmetic sequence. Sorry, can't spell. All right, so I guess if we wanted to find the nth term, just say it's n1 is going to be equal to, sorry, n is equal to 1. We have the first term. First term is going to be equal to 5. 5 is going to be equal to our starting number 5 plus 0. Our second term, we've got 9. So it's going to be equal to 9. We've got our starting term plus that difference of the 4. If n is 3, our third term is going to be equal to 13. That's 13 is going to be equal to our starting term plus our difference plus our difference. If n is 4, the fourth term is going to be equal to 17. So 17 is equal to our starting term plus our difference plus our difference plus our difference. So the nth term is going to be equal to our starting number, the 5, plus, since we're adding, and then it's going to be the difference, which is 4, and then n minus 1. Number 4. Let's see what we got. 6 to 30, we have multiplying 5. 30 to 150, we're multiplying 5. 150 to 750, we're multiplying 5. And 750 to 3750, we're multiplying 5. So because we're multiplying, this is a geometric sequence. And let's just find the nth term. The nth term, so n is equal to 1. Our first term is equal to 6. So that would be 6, our starting number. It's going to be equal to 6 times 1. We're multiplying because it's the geometric. And then n is equal to 2. Our second term is going to be equal to 30. So 30 is going to be equal to 6 times our difference of 5. And 3, our third term, is going to be equal to 150. So that would be 150 is equal to 6 times our starting number times 5, our difference, times 5 again. And then n equals 4. The fourth term is going to be equal to 750. 750 is going to be equal to 6, our starting number, times our difference, times our difference, times our difference. So the nth term is going to be equal to our starting number, the 6, times, because we're doing geometric, our difference of 5. And that would be n minus 1. All right, says number 5, it says decide whether the argument is an example of inductive or deductive reasoning. The last 4 answers were false, therefore the next will be false. I think that it is inductive because we've already seen that it's true, so we're going to assume that the rest is true. Could be wrong, but that's my opinion. Write the specified statement. State the inverse of the following. If you study hard, then your grades will be good. So in order to do that, we need to find out inverse is equal to the opposite meaning. So that would mean if you study hard, it would say if you do not study hard, then your grades will not be good. So it's like the total opposite meaning. So if you study hard, then your grades will be good. If you do not study hard, then your grades will not be good. So it's like the opposite meaning. All right. So number 7, it says state the contrapositive of the following. If he is in school, then he is well. Now, the contrapositive is the opposite of the converse, which that means it's the negative meaning and negative position. So that would be if he is not well, comma, then he is not in school. Because it's the opposite positions and the opposite meanings. Okay, so this says solve the problem. The number of dogs and chickens on a farm add up to 14. The number of legs between them is 36. How many dogs and how many chickens are on the farm if there are at least twice as many chickens as dogs? So show your method clearly. I kind of did like the guess and check method. I started with like 10 dogs. I just started randomly. The 10 dogs would have 40 legs, and 4 chickens have 8 legs. And that would give you a total of 48 legs. And we're looking for a total of 36 legs and 14 animals. So I have 10 dogs and 4 chickens. That's the total amount of animals we need, but it's too many legs. So I kind of needed to go down and see, okay, if I go down, what happens? So then I did I did 8 dogs has 32 legs. Now if I lower the amount of dogs, I have to raise the number of chickens. So that would give me 6 chickens. And then 6 chickens has 12 legs, giving me a total of 44 legs. So I'm getting closer, but not quite. And then next I went down again. I did 6 dogs. 6 times 4 is 24 legs. And then because I lowered the dogs, I have to raise the chickens. That would give me 8 chickens. 8 times 2 legs would be 16 legs. So the 16 legs plus 24 legs is equal to 40 legs. Then I thought we're getting closer, so I went down a little bit less. I went 5 dogs has 5 times 4 is 20 legs. And then 9 chickens would have 18 legs. And that would be 20 plus 18 would be 38. So close. And then I was like, okay, let's try 4 dogs. Would have 4 times 4 would be 16 legs. And that would give me 10 chickens. Because 10 and 4 is the 14. So 10 chickens gives me 20 legs. So 20 plus 16 gives me the 36 legs that we're looking at for the answer. And it says if there are at least twice as many chickens as dogs. So 4 dogs, twice as many dogs would be 8. So it's definitely more. than twice. Okay, next question. Number 9, it says, find the number of subsets of the given set. Now, a set is any number of items that are grouped together. It could be like 1, 2, 3, 4, 5. That could be set A, or it could be set B, could be, let's see, A, B, C, D. Now a subset is any, now each number or letter or whatever that you're grouping, so each one of those is an element. So like the number 1 is an element, the number 2 is an element, the number 3 is an element, and that's notated as like this symbol right here. It looks like an E. Number 1 is an element of group of set A. Number 2 is an element of set A. So to find the number of subsets, a subset is any number that's included in a set. So like say the set ABC. It could be A, it could be B, it could be C, it could also be A, B, or B, C, and it also could be A, B, C, A, C, or it could be nothing. All right, sorry for the interruption. We've got also could be like none of the elements would be in that subset. And then also the last one would be all of them, A, B, and C. So the answer would be 1, 2, 3, 4, 5, 6, 7, 8 would be 8. There is a formula to give it to you a lot easier. If you think about it, in each one of these elements, it could or couldn't be in the subset. Like in this first one, A, it has A, so A is in there, but B and C is not. So it's either in there or it's not. So what you would do is you would multiply 2, because there's 2 options if it could or couldn't be in, times the number of elements in that set. So that would be 3. So 2 to the 3rd power would be 8. So that would also work, say, if you had a subset that has 6 characters in it. 6 would do 2 to the 6th power. That would give you how many subsets are in that set. But our answer would be 8 in this case. Now number 10, it says, what is the relationship between sets A, if A has A, B, and C, and B has 1, 2, 3? That would mean they are equivalent. They're equivalent because they have the same number of elements. They would be equal if they had, each element was the same. So like say A had A, B, and C, and B had A, B, and C. They would both be equivalent and equal because they both had the same number. And being equal means they have the same elements as well. But this one is equivalent because they're not the same elements. They're just the same number of elements. Okay, number 11. All right, so number 11, it says, given that n times p equals 11 and p subset of Q? What is the least number of elements that set Q can have? Is there a maximum limit on the number of elements that set Q can have? Explain. Okay, so that's just a bunch of mumbo jumbo that says N is, so N is the number of elements in a set. So just like I said up here, like this one has 3 elements, A, B, and C. Now it says, so if set P has so many elements, it has 11 elements. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it has 11 elements. And P is a subset of Q. So then we have Q. So that means P, that means P has to have all the elements of Q in it, at least. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So if Q has to have at least that number in there to be considered a subset. And then, so it has to be at least 11 to be a subset of the Q. Hope that makes sense. So like, it couldn't be a subset if it didn't have all the numbers that were in Q. Like P couldn't be a subset of Q if it didn't contain all the numbers. Q could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, because all the letters that are in P are also included in Q. It could be a subset of Q. It doesn't have to have all, it just has to have all the ones that are in the subset. Hope that makes sense. All right. This says solve the problem. Set A is S, E, T, and F. Show that the B subset A and B proper A okay, we're working on the problem. To solve the problem, set A is equal to S, E, T, and F. Show that B is a proper subset of A, and then also B is a subset of A. So if we want to work on the proper subset, it would say that for a proper subset, it says that it's a subset where there is at least one element of one that is not in the element of the other. So let's see, for B to A, if we had B subset would have like S, E, and T, that would make it to where B is a proper subset of A. But if we had B is a subset that has all of the letters included, that would be considered a subset. That would be B, a subset of C, or of A. That means like all the elements in B are also in A. Where here, not all of the elements are in there, but it is a subset of it. Okay, number 13, it says represent the following sets by listing the elements and using a Venn diagram. So let's see, if we have 3 sets, or let's say 4. So one set would be A, see, A is going to be equal to 1, like set 1, 2, 4, and 5. B is going to be equal to 1, 3, and 6. We're going to have C, it's going to be equal to 1, 7, and 8. And then U, the universal set for all of these, that's going to be equal to, so we have 1, 2, 3, 4, 5, 6, 7, and 8. So like the universal set has all of the ones that are included. So we're going to draw this in like a Venn diagram. To do that, you draw a box, and it's the U is the universal set. So then we're going to have 3 circles. 1, 2, and 3. Then each circle represents a set. Like let's say this is set A, set B, and set C. If A has the numbers, all right, let's find the common numbers for all of them. They each have a 1. Oops. They each have a 1. They have 1, 1, and 1. So that would be to where they all share a number. And then let's see, only A has a 2, a 3, B only has 3, 4 is A, 5 is A, B is 6, and then C is 7 and 8. So see, the universal set, everything that's inside this rectangle is included in A, B, and C. In order to find the A subset B minus C, we want to find everything that's included in A and B, but that's not included in C. So if we want to do it just by looking at the numbers, that would be, or let's do this, make it a little easier. We'll do a green. So everything in A and B, the subsets, that's not included in C. So A subset of B minus C would equal 2, 4, oh, hold on. Be 2, 3, 4, 5, and 6. So then if we wanted to find, using those same sets, if we wanted to find B, the A subset C minus B, that would give us, oops, everything that is in A and C, but not in B. So we have A and C that's not in B. So that would be for the subs or the universal set A U B minus, oh, should be a C, minus B. That would give us the set 2, 4, 7, and 8. Hope this is making sense. If not, let me know. All right, so now the easy part. We're reviewing the bases. So we want to do 42 base 5, and we want to change it to 10. So that means we would be multiplying each place value by the value of that place. So In a base 5 system, it would be 5 to the 0 and 5 to the first power. So 2 times 1 is 2, and then 4 times 5 is 20. So you add those together. It's equal to 22 base 10. So your answer would be 22. Then number 15, we have 436 base 8. And we want to change that to base 10 as well. So same thing. We're going to take 6 times 8, or 6 times 1 is 6. 8 times 3 is 24. Plus 64 times 4 equals, sorry, I got to sneeze 1 second. Sorry about that, I had to sneeze. All right, so 8 to the 4th, or 8 to the 2nd power times 4 is 256. So that would give us 286 base 10. All right, now we have number 16. We have 24 base 6, and we need to change it to base 5. So we need to do is get it to 10 and then 10 to 5. So we would do times 4 to the 6, 4 times 6 to the 0 power, and then 2 times 6 to the first power. So 4 times 1 is 4, adding to 6 times 2 is 12. So that's going to give us 16. Sorry. 16 base 10. So now we want to go from base 10 to base 5. So in order to do that, we need to find the place values if we're going into a base 5 system. So it'd be 5 to the 0 be 1, 5 to the first would be 5, 5 to the second, 5 times 5 is 25, and we're going to be dividing it into the 16. So we know that 5 square root of the 25 is too big, so we're going to start with 16 divided by our first group, like our 5. So 5 is times 3 is 15. It's going to give us a remainder of 1. Now we don't have we need a remainder of 0, so we got to keep going. So then next digit we'd go as the 1. So we have the remainder 1 divided by the place value. So 1 divided by 1 is 1. Gives us that remainder of 0 that we're looking for. So our answer would be the 31 base 10. So what we found is 24 base 6 is the same as 16 base 10 is the same as 31, or 16. Oh, sorry. My bad. Okay, so what we found is 24 base 6 is the same as 16 base 10 is the same as 31 base 5. So your answer is 31 base 5. And that is all for homework number 2. If you guys have any questions, please don't hesitate to call. I'll work on getting some of the outline videos out soon. Thanks.